In this video, we will look at a problem of finding all possible combinations from the given integer array. Here is a sample input array, and here are all the possible combinations that can be generated from this array. One thing we need to see is how many total number of combinations can be there. So total number of combinations can be generated by using this formula, which is 2 power n. Here n is 3, as there are 3 elements in the array. So there are 8 combinations which will be generated from this array. For generating all possible combinations, we will need to list down the first 8 numbers in the binary form. 0 can be written as 000 in the binary form, 1 can be written as 001, 2 can be written as 010, and similarly I will be writing down the first 8 elements in the binary form, and then we will see how can we generate the possible combinations from this formula. I have written the binary representation of the first 8 numbers. To further clarify, let's mention the indexes as well. So this is the second index, then we have first index, then we have 0 index. So now we will only include the index from the binary representation whose value is 1. Like let's start off here. uh, all the elements are 0, so our output set will be empty. Here the 0th index is 1, so we will only include the element which is at 0th index. From our input array, element 2 is at 0th index, so we will include 2 here. Next, only element at first index is 1, so we will include the element at first index here. Here elements at 0 and 1, both index are set to 1, so we will include both elements. And similarly we can fill the remaining combinations as well. We just need to remember the basic formula that in the binary representation, if the bit is 1, we need to pick the element at that index from the array, and that's it. With the help of this we can generate all the possible combinations. Now let's look at the Java code of this problem. Regarding the Java part, I have written the basic skeleton. This is the main method which will call the get all combinations method and will display all the combinations onto the console. This is the method we will be writing for generating all possible combinations. Now additionally we will be requiring a helper method which will determine whether a bit at a certain index of the given number is 1 or 0. Let's write that helper method first, and then we will see how can we use that method in our get all combinations method. Let's return boolean from the method, and let's call it check if bit is 1. Parameters will be number and the bit. We want to check if it's 1 or 0. So determine if whether a bit is 1 or 0. There are two things we need to do. First of all, we need to perform left shift onto the bit number, and then we need to AND it with the number. This way we can determine whether the bit is 1 or 0. We will also drive through this to exactly understand how this code piece of code will work. So if check is 0, you can simply return bit is not 1, otherwise it's true, that means that bit is 1. Let's suppose the given number to us is 5. uh, 5 in the binary form is 101, and let's say we want to see if this second bit is 1 or 0, or that means bit is 2. Now first of all the number is 1 like this. Now we need to left shift this 1 by 2 since bit is 2 here. So at first step, if we perform the left shift, it will become 0 1 0, and then after if we do another left shift, it will become 1 0 0. Now we need to AND this both numbers, check it's 1 0 0, and it will be ending with this number. Number is 5, which is 101 101. Let's perform the AND operation. We know that if both the bits are 1, only then the resultant should be 1, else it's 0. So it will 1 1 is 1 0, and 0 1 is also 0. So this is the number we have in the check at the end. So that means this number is not equal to 0, so in this case true will be returned, which is actually the correct result because the bit at the second index is 1. Let's try through another one. If we want to see if the bit at the index 1 is 0 or 1, it will be 1. Now we need to perform left shift only once, so our number will look like this: 0 1 0 0 1 0. Now we need to AND this 0 1 0 with the number 5. You can see that 0 1 will become 0, 1 0 is 0, 0 1 is 0. So in this case all the three numbers will be 0, and our resultant check element will have 0 in it, so it will return false, which is actually true, that the given bit is 0. So with the help of this method we can determine whether the given bit is 1 or 0. Let's write the get all combinations method now. First thing we need to check is how many total number of combinations are there. Since we know that the total number of combinations is 2 power n, so let's calculate it using math dot power utility method. We need to calculate 2 power n, and n is basically array dot length. This method returns double, so we need to cast it into the integer. Now let's loop through it. I is equal to 0, I less than total I plus plus. Next we need another loop so that we can check the each index of the element in its binary form. And j is equal to 0. Now j, the total number this loop will iterate depends upon how many indexes of the number we want to check, and it will depend upon how many elements are there in the array. So it's arr dot length let's create an integer array for combination here, where we'll be storing each generated combination. Now simply check if uh, check if bits. So we need to determine if the bit is 1 at that specified index. We need to simply include it into the combination dot add and arr of j. It will add the that element into the array, and at the end of this inner loop we will add this combination into the overall combinations array. Combinations dot add combination. So this way we can generate all the possible combinations. Now let's test our code as well to see if this functions well and according to our expectations or not. I have forwarded 246 as the input. Now let's run this code, and you can see that it has generated all the possible combinations: 24, 24, 6, 2, 6, 4, 6, and 2, 4, 6, and there are total number of 8 combinations into the output. Let's try it on another input as well. So it's also generated well. Let's try it only on the 2, and it will generate the total possible combinations as expected. I haven't added null checks here. You can always add them, or you can ask me if you need any kind of help in the comment section. I have also posted another video of determining all possible combinations, and that method doesn't use the bitwise operator. I will be also be mentioning the link of that video as well, so you can use any method if you want to use bitwise, and this is the one you have seen in the current video. Otherwise you can use the other method for determining all possible combinations as well. Thank you very much.